Hello and welcome to the first segment of Windows Enumeration, the 22nd video as part of our Red Team Fundamentals mini-series. Over the past several videos, we have been discussing several important components of Sliver and understanding its operations from a Red Team perspective. We discussed the usage of general commands, how we can loot discovered sensitive information, as well as how we can execute third-party tools, whether they are in the form of managed or unmanaged executables. In this video and the next, we will apply what we have learnt and examine how we can perform local Windows system enumeration to gain a better understanding of our target environment before attacking it. As always, everything we teach in this video is purely for educational purposes. We accept no responsibility for your actions. Now, before we begin our journey into system enumeration, I have decided to divide this large section of our mini course into two videos. More specifically, this first segment will cover the majority of enumeration techniques that we can perform and gather manually. And then in the next video, we will examine several automated methods of doing so using tools like Wimpy's and Seatbelt. So we will begin by enumerating general system information such as operating system version, build and architecture. Following this, we will examine our user account in greater detail, including its privileges, group memberships and environment variables. Then we will examine more detailed system information, including running processes, important registry values, active services and scheduled tasks. And to finish off, we will review network information, gathering interface configurations, active network connections, various caches, and several other important observables. It is important to note that much of the information we gather throughout these two videos is purely to help us understand the system we are working on. As we delve into persistence and privilege escalation, we will revisit the enumeration points that are relevant when performing a particular technique. These videos will therefore focus mainly on understanding our environment before we step into the world of Windows system attacks. Now, before we proceed, there are several important components of Sliver that we need to install. And the reason for doing so is because Sliver only provides a limited set of commands used for system enumeration and to enrich our data and gather more observables. There are several armory tools that we need to install. Now, these specific tools that I'm talking about is actually a bundle, and that bundle is named situational-awareness. And as you can see here, once installed, it provides us with a comprehensive amount of commands that we can use to enumerate the local system. And to install it, you can use armory install with the argument of the specific bundle or tool that you are installing. Now, one of the first commands that we will take a look at is called info. Now, we touched upon this command in one of our previous videos, but if we execute it here, you'll see that we get a short summary of our Sliver implant session. So you'll see here one of the properties is storing the host name of the target system. We also have the user under which our Sliver implant is running under, including its user ID and also its primary group ID, and then some other information regarding our target system. Now, amongst the most important properties here is the version property, and its purpose is to provide some information about the specific release of the Windows operating system. So here you can see we've got the build number, we've also got the architecture. However, the most important value as part of this property is going to be the build number. Now, whenever you're exploiting the Windows kernel or other Windows component, this build number will help you pinpoint the specific release of the Windows system. So if we take a look at Windows 11's version history and scroll down here a little to the versions table, you'll see that our specific build was released in October of 2023. So that's already 3 years ago. Now, since then, if the system was not updated, it could provide us with several opportunities for exploitation, be it for bypassing certain components such as the UAC or performing some means of privilege escalation by abusing the fact that the Windows system is out of date. Of course, this is beyond the scope of this video, but hopefully you can see how the build number can help us better identify the target Windows system. Now, beyond the general system information, we can dive a little bit deeper, and to get a better understanding of our target user, we can use the whoami command. Now, once executed here, you'll see that we get some more information regarding the current session's execution context. So here you can see the logon ID, essentially the logon session of our user that has executed the implant. And then also we have the current token ID, which essentially specifies the current access token that is applied to our Sliver implant. Now, we will get into these two properties a little bit later in this mini course, but the main thing to take away here is that the execution context will dictate what we can and cannot perform on the target system. Now, another way we can understand what we can perform on the target system is by listing our privileges, which can be done using the getPrivs command. So if we execute this command here, you'll see that we get a nice little outline of all of the privileges that are assigned to our user. So in the name column, you can see that we get the name of the specific privilege. And then in the description column, we get the description of that specific privilege. And then the attributes column essentially highlights whether that privilege is disabled or enabled. Now, one important property of all of this is the process integrity level. And this level defines the execution context that our user has. Now, there are several different properties. There's low, medium, and high. For the most part, it will be medium. But as you'll see later in this mini course, the high level helps us bypass certain restrictions such as the UAC. Now, another way we can get a listing of our user, its privileges, and the groups assigned to our user is by using the sa-whoami command. So as you'll see here in its description, it outlines that it returns information that is similar to using the native Windows whoami command with the all switch. So for instance, if we were to use execute to execute whoami with the all switch, as you'll see here, we obtain a lot more information about our user that was not visible with the whoami command. Now, because this way of execution is deemed bad OPSEC, by using the sa-whoami command, we can obtain the same information whilst keeping our operations in memory. So as you can see here, we get the username under which our Sliver implant is running, that user's SID. Now, another observable that is really useful here is the group information. Now, it can be a little bit difficult to read, so I'll zoom out. And the group information highlights all of the groups that our user is currently part of. Now, as you will see when exploiting Active Directory networks, the domains groups that we are part of will help us understand the permissions that we have over that domain. That is, any specific privileges we have over domain objects, and so on. And additionally, any local groups that we are part of will help us understand the local permissions that we have over the system. And then additionally, as we use getPrivs, we get an outline of our user-specific permissions. Now, another useful enumeration point is the environment variables. And these store the configuration settings that influence how processes and applications behave. So if we execute the command here, you'll see that we get a listing of all of the environment variables that is defined for our current session. So as you can see here, some environment variables store the properties about the target system. In this case, its hostname, if applicable, the logon server or the domain controller of the network, the specific OS, the architecture of that system, and then additional properties regarding that specific system. Now, in some cases, environment variables can store sensitive information such as clear text credentials. For instance, say a developer needs to reuse a specific command, and that command requires the developer specifying their password. They can set that password as an environment variable and then reuse it as necessary. Now, although that is a very specific example, just note that it is possible to come across. Now then, having understood the more higher level layer components, let's take a look at some of the lower ones. And one of the first commands here I want to showcase is the ps command. And this command simply lists all of the running processes on the system. And by listing the processes on the system, we can gain a better understanding of the applications and other programs that may be running on it. Now, if I execute ps, you'll see here that we get a truncated overview of all of the running processes. Now, to scroll through the list, Sliver will prompt us to do so, and we can simply select Y and continue to do so for as long as we want to enumerate the processes. Now, every process will contain its process ID, its parent process ID, the owner of that running process, the architecture of that running process, the actual executable of the running process, and the sessions identifier specifying whether the process is running under the context of our user, in which case you will see 1, and then -1 or any other value for any running processes that is not running under our context. Now, you'll also see some processes marked in red. Now, these types of processes will often indicate that it is part of an antivirus solution, EDR solution, and essentially any process that may defensively hinder our operations. Now, in the case of MSMPENG, this is Microsoft's malware protection engine, which is part of Microsoft Defender. And because it is running, it may indicate that a malware protection service is in place. Now, there are other categorizations. For instance, here you can see one of the processes is categorized in green, and this process describes our Sliver implant. Now, conveniently, at the end of the output, Sliver presents all of the identified security products. And in this case, the only detected product was Microsoft Defender. And we previously saw this by identifying the process that was MSMPENG. Now, besides that, perhaps the most important column is executable, because again, it helps us identify the running processes on the system. So for instance, the presence of OneDrive may indicate that OneDrive is running. The presence of VM tools may indicate that the system is a virtual machine, and the list goes on. Now, we can also use the PS command with several different switches, and one of those switches is the E switch, and this switch helps us filter for a specific process. So say, for instance, we are searching for a specific process, say MSMPENG.exe. By executing this, you'll see that we get an outline of whether or not the process may be present, which in this case it is. Now, we can also filter by a process's ID, and to do so we use the P switch. So taken from this example, the process is 3456. Using the P switch and specifying that as an argument will also list that running process. Now, another useful switch is the C or print command line switch, and this switch will print out any command line arguments that were passed to the running process. So for instance, if we wanted to find out whether MSMPENG accepted any command line input, we can run it like so. And in this case, it is not visible and we only have the name of the executable. Now, the reason for why this happens is because some processes may be running outside our current user's context, and any other process, say running as the local system user, we will not be able to inspect the command line arguments because we would have no permissions of doing so. So really, we can inspect any command line arguments of our own processes. Or if we have administrative access over the system, then essentially any process. So let's try to find a process that we own. So as an example, let's take OneDrive. And then if we remove the executable here and specify the PID of OneDrive, now you will see that we get a listing of its command line arguments, because again, we have the permissions of doing so. Now, in this case, it is not really that useful, as from the perspective of lateral movement or privilege escalation, we are not revealing any sensitive information. However, if we are lucky and do enough enumeration, we might find some processes that may reveal such information. For example, in this case, the psexec program is being used to launch a remote command over the Web1 system. And as you can see here, as part of the command line arguments, a set of credentials is passed to it. Now, another useful area for enumeration is the Windows registry. Now, this registry can be found on every Windows system, and all that it is a hierarchical database that stores system settings and program configuration options in a standardized format. Now, primarily, it is used to store and retrieve information by low-level system components such as the kernel, device drivers and services, any installed applications, the SAM database, and really any other component or program that may require it. Now, from the perspective of enumeration, the registry can be enumerated to obtain the system build information, any usernames, and potentially passwords. And it is an invaluable source of information during enumeration. Now, navigating the registry can be quite complex. So before we enumerate for the registry items, let's just take a look at how we can list the registry keys and values. So to list the keys, we will use the list subkeys argument. And then to list any values under those keys, we will use the list values argument. And keep in mind that the command that we use for all of this is the registry command. Now, when listing registry keys, we will have to specify the hive under which those keys are present. Now, in most cases, when you are enumerating a system from a non-privileged context, the hive that you will often be after is the HKCU hive. And this hive often stores all of the configurations for that particular user of a system. Now there is also the HKLM hive, which stores the local system configuration files, but because it often requires privileged access to read, we will often be using the HKCU. And then in addition to the hive, we will have to specify the registry path. All right, so let's specify the H switch with the HKCU hive. And to list the topmost keys under this registry hive, we can leave the registry path as empty. So if we execute this command, you'll see here that we get a listing of all of the topmost keys. And then when we want to view additional keys, also known as subkeys, that may be found within the parent key, and we will simply specify that parent key as part of the registry path. And once executed here, you'll see here that we get two subkeys that can be found within the parent system key. And then we could continue going down this hierarchy by specifying a backslash with the name of the subkey. So executing this, you'll see here that we get two additional results. And then we could continue going down this path of subkeys until no more subkeys are found. So as you can see, listing keys is pretty straightforward. Now, as for listing values under those keys, the command line arguments are pretty much the same. So we need to specify a registry hive and then the path to that registry key that contains a set of values. So for instance, the current version registry key stores information about the current Windows system. And then you can see here all of the values it contains. And these values are the values that are storing the relevant information. Now, to read the registry key, it is pretty much the same as the previous two commands. We specify a hive and then the registry path to the specific value of whose contents we are reading. So say, for instance, we wanted to read this value that is product name. We would copy this value and provide it for the read argument. And then once executed here, you'll see that we are presented with the listing of its contents. Now, in this case, the product name value contains information about the system's configuration. So in this case, we can see that we are dealing with a Windows Pro system. Another useful value here is DisplayVersion, and this value contains a human readable version of the specific Windows build. And then there is a lot more values that can be read here under the current version key. I suggest you take some time after this video to explore some of these. Now, another useful registry key that contains additional subkeys of interest can be found under current version uninstall. And as you can see here, I'm currently listing both of the registry keys under the HKCU hive and then also on the HKLM. And basically all of the listed subkeys here represent the installed applications on the system. Now, although I only have a couple of applications installed, whenever you want to inspect the specific components or properties of that installed application, we can copy its subkey and then we can list all of its values underneath it. So specify list values. Now, although these values will differ depending on the application you may be assessing, but one of the standard values here is DisplayVersion. And what this value represents is the installed version of that particular application. So as you can see here, listing the version of Google Chrome, we are running a significantly outdated version. Now, because some applications may be vulnerable to something like local privilege escalation, by reading these values, we can better understand the specific version of that application. Now, in the case of Chrome here, I don't believe there is any local privilege escalation points that we could abuse here. But because it is so outdated, we might be able to extract the credentials that may be stored within it. Now, of course, we won't be doing it in this video, but the key principle or the key takeaway here is that by listing the value of DisplayVersion under a specific program's registry key, we can obtain the installed application's version. Now, of course, there are a lot more registry keys available within Windows that expose system information, but we will discuss those as we progress through the mini course. So for now, just note that Windows NT current version lists information relevant to the local system. And then under the current version uninstall subkey, both within HKCU and HKLM, lists all of the installed applications and their version information. Now, another useful area for information is the running services on the local system. Now, services are fundamentally the same as any other application on the system, However, these are long running and operate in the background. And often you'll see that they provide some sort of functionality to the system. So for instance, a Jenkins server service may be running on the local system that may provide access to the Jenkins instance. And we can enumerate for such services using the SASC command. Now you can also specify a host name of a remote system for which services you are enumerating, but by default, it will list all of these services that are running on the local machine. So if we use this command here, you'll see that we get a listing of all of the running services on the local system. Now a service has numerous different fields. For instance, the state service specifies whether or not that service is still running. The binary path name specifies the location of that specific service executable. Another useful one here is the service start name field, which specifies the context under which the service is running. So in this case, you can see that the service is running with the most amount of privileges, that is the local system user. And then another useful one is command line, and this field specifies the command line arguments that is specified to the service. Now again, remember, we will require certain permissions to view the command line arguments of certain processes, and in this case services. But the main principle here is that by using the SASC command, we can enumerate for all of the running services on the local system. And you'll see how all of this will be useful when we get to persisting system access and also escalating local privileges. Now, in a very similar way as enumerating for local services on a system, we can also enumerate for local tasks. Now, in comparison to a service, a scheduled task executes in a response to a predefined trigger, also known as a condition. So really, it executes periodically rather than consistently as a service would. But the fundamental nature of these two is that in some way or another, they would be providing some sorts of functionality to the system. And in the case of a scheduled task, this may be running a script, sending an email, or whatever it may be. So if we execute this command, you'll see that we get a listing of all of the local system pre-configured tasks. And you'll see much of these same properties that apply to a service apply to a task. For example, the principal element defines the specific account under which the task runs, whether that task is allowed to be started on demand, whether it is hidden. Scrolling down here a little, you'll also find the exec element, and this defines the specific command, including its arguments that are executed. And again, we'll get into much of this when we perform persistence and local privilege escalation. Now, in addition to what we've already discussed, some network information can also be very useful to understand the system we are dealing with, the domains that the system has communicated with, the configured network routes of that system, and other information that may be network relevant. So one of the first commands here that we will explore is the ifconfig command. And this command simply lists all of the network interface configurations. Now, by default, we can just run it as is. And as you'll see here, we get a list of all of the configured network interfaces on the local system. So here we can see the specific IP address of that system, additionally the network range, and then also the MAC address assigned to that interface. Now, by default, it will only list those network interfaces that are running IPv4, but by using the A or all switch, we can list all of the network adapters, including IPv6. So if we specify that, you'll see here that we get a listing of the IPv6 address here, and then additionally the loopback interface, which was hidden by default. Now, in addition to the regular ifconfig command, we also have the saipconfig command. And much as the normal ifconfig command, this will list the interface configuration, including any IPv4 addresses, the MAC addresses assigned to those interfaces, the host name, any DNS suffixes, and DNS servers. So if we run this command here, you'll see that we get a much more enriched output than we previously got with ifconfig. Most importantly here, we can see the host name of the local system, the DNS suffix of that local system, and then the DNS server. Now, these two properties here relate to the Active Directory instance that the system is connected to. So as you can see, this command here can also be used to enumerate the domain that we may be part of. Now, in addition to the interfaces, we can also print the routing table. Now, if you don't know, a routing table fundamentally defines the rules that determines the best path for data packets to reach their network destinations. And if we execute this command here, you'll see here that we get a listing of all of the network destinations, the gateway that is used to reach those destinations, and then other relevant values that are applicable to the local system's routing table. Now, if our system communicates to any other segmented network within the broader network, the routing table can help us identify that network. Another useful command is netstat, and this command helps us establish the network connection information that is associated with our host. So if we execute this command as is, and if we take a look at the output, you'll see that we get a massive listing of all of the connections that the local system has established. Now, the local address column will define the local IP address of the underlying system, and then the foreign address column will define the remote destination for where the connection is established to. Now, there are various different switches you can use with this command, and perhaps one of the more important switches is the L or listen switch, and this will display the information about any listening sockets on the local system. So if we execute the command and provide it with the L switch, and we will get a listing of all of the programs and services that have established a listening state and may be listening for connections from remote systems. And this is quite useful to observe any services that may be running on a local system that may be potentially abused. So for example, taking one of these values, we can see that the SVC host application is listening on port 3389, which may potentially indicate that RDP may be exposed to the host. So fundamentally, this listing is good to understand the applications that are running on our local system and applications or services that could be potentially abused. Another useful source of information is the ARP cache, and this can be viewed using the SARP command. And all that this command does is lists the ARP table entries, that is IP to MAC address mappings, with all communicated hosts. So if we execute this command, you'll see here that we get several listings of the communicated to hosts. So for instance, 10.0.9.5, 10.0.9.13, and other values that may be potential targets within the local network. Similarly to the ARP cache, we have the DNS cache, and this can be viewed using the sa-list DNS command. And again, as you can see in its description, it lists the DNS cache entries with their record types. So if we execute this command, you'll see here we get numerous different records for which the system has communicated with. So here we could potentially identify additional targets of interest, perhaps maybe some web servers that may be running on those targets, and overall just get a better understanding with who the system communicates with. And finally, the last enumeration point of interest are the firewall rules. And this can be enumerated using the sa-list firewall rules command. And as you can see here, all that this command does is list all of the firewall rules that are configured on the local system. So if we execute the command as is, you'll find all of the rule configurations. So for example, if you are setting up some communication channels for remote data exfiltration, you can examine these rules to see what is allowed in, what is allowed out, and then make best judgments of how you are going to perform that exfiltration. And thus by listing the firewall rules, we can better understand that. And that concludes our first part of Windows enumeration. I hope you found this video informative. In the next video, we will take a look at a few tools that can help us with the enumeration process, speeding up our information gathering and enriching the intelligence we collect. Whilst we've only scratched the surface here, in that video, you will see how external tools like Wimpies and Seatbelt really complement manual enumeration. In the meantime, feel free to join our Discord channel to stay up to date with us, explore our courses, soon to be released labs, and one of the finest red teaming courses available. I've left a link to our group in the description below. Until then, stay safe, and I will see you in the next one.